Anyone who has coded a Java program before has seen strings, because everyone probably started with a Hello World program, and in that program you write system.out.println and in quotations hello world. And that part in quotations is a string. So what is a string, and why is it different from other variables in Java? Now most likely the variables you've seen in Java so far are integers, doubles, chars, floats, maybe bytes, booleans, and these primitive variables in Java each have a fixed size. So an integer is 4 bytes, a char is 1 byte, a float is 4 bytes, and a double is 8 bytes. And these types always have the same size, so every single integer is always going to have 4 bytes. But a string, on the other hand, could have anywhere from 1 character to 10 characters to like 1,000 characters, as many characters as you want. So because of this, strings in Java are objects. And because they're objects, they have special methods, and also in Java, there are special constructs to work with strings. And I'm going to get into some of the basic methods and some interesting things you could do with strings. Alright, so let's get into some concrete examples with this. First of all, declaring a string is as simple as declaring a regular variable. So let's declare a string s, and we can print it out just like any other variable. And down below, you can see hello has been printed out. So let's go over some of the basic methods of the string class. So first of all, the length method. This will return the number of characters in the string. So for hello, it prints out 5. Simple enough. Okay, so moving on, the char at method. Now this method takes in an index and will return the character at that index. So it will return a char, and then we pass it a zero-based index. So what that means is that the first letter is at 0, and then the last letter is at the length -1. And this can be a little tricky. Let me show you why. So first of all, just print out the 0th character, and that is H. But if we want to print out the last character, this is not it, because s.length will return the number of characters, and that will return 5. But if you count it here, we have H at 0, E at 1, 2, 3, and the O is at 4, not 5. So if we run this, we'll get an exception. So what we really want is length -1, and that's how to get the last character. Okay, so another useful method of the string class is the index of method, which is sort of the opposite of char at. So there's plenty of different parameters we could send to this. So the first one, we could just send a letter, and what this will return is the first index of that letter. So we put an E and it returns 1 because the first occurrence of E, or the only occurrence, is at index 1. And if we have another index in here, or another E in here, it'll still print out the first one. And if we put in a letter that's not in the string, like Y, it will return -1. Now, we can also include an additional parameter which sets the offset at which it searches. So if we don't want the first occurrence, we could say, okay, start searching for the letter E starting at index 4. Right, so skip all of this and then start searching. So 6. So it returns this one because it ignores this one. And there's also the same exact methods, but instead of a character, we can do a string. So this is useful if we want to look for a word within a sentence or something. So we have, let's say we have 2 worlds, and we can leave the 4 because that's still before the first world. And it will return 6 because W starts at 0, 1, 2, 3, 4, 5, 6. Right, so it's going to return the starting index of that entire string. And again, we can leave out this parameter if we want, and it'll start searching from the beginning. Otherwise, we can include it and include an offset at which we want to start searching. And that's index of. Okay, so now let's move on to something a little bit more tricky and kind of use all the knowledge that we know with these methods. So the substring method will return a piece of your string. So you can provide it the starting index, 1, and then the end index, which it will return the characters up to but not including. So let's make a new string, s2, and have it equal s.substring 1, 4. So what this does is it'll start at index 1, which is E, and then it'll go up to but not including index 4. So here's 1, 2, 3, up to but not including 0. So it should print out ELL, and sure enough it does. But the substring method you can call in two different ways, similar to index of. You can only pass, or you could pass just one integer. And what that'll do is it'll start at that index and go to the end of the string. So starting at index 2, it'll print out, or it'll take out that part of the string. And there we go. Okay, so now that we have these methods down, how do we work with more than one string? So let's make s2 equal to space world. So simply enough, to concatenate two strings or put them together, we just use the plus operator. So s plus s2. And that makes a new string with them concatenated. So hello world. So that's simple enough. And we can also do, we can also test strings for equality. So it's not like testing primitives with equality with the equals operator. For strings, you need to use the equals method. So nothing's printed because they're not equal, but if I make them equal, there we go. So this will check if they're exactly, if each character matches each character, but it doesn't check for case. So these are not equal because this one has a capital H and this one has a lowercase h. But we can say, or we can use the equals ignore case method, and that will test for equality ignoring the capitals and lowercases. So now they're equal because we use equals ignore case. So in addition to the equality method, we also have a compare to method. So what this will do is it will return an integer based on whether the first string is alphabetically less than, equal to, or greater than the other string. So just one thing you need to know is that in ASCII, how letters are ordered, the capitals are first, so first you have the A through Z, and then the lowercase. So actually, B, capital B, is before A, which, you know, might not make sense, but it makes sense if you think about how the letters are ordered in ASCII. So let's just... So this will return a negative integer if S is before S2. It'll return 0 if they're equal, and greater than if S is alphabetically after S2. So since S is A, it's before B, which makes sense. And like I said, B, capital B, is before A, which doesn't make sense, but it makes sense if you think about it in ASCII.